Welcome to qnawire.
Okay, so the mass of our acid, according to the exercise, is 0.446 grams. We also have a concentration for KOH of around 0.105 mole per liter. Finally, the acid is monoprotic. So monoprotic simply means that it will give one proton. So the equation is like this. HA will react with OH minus to give us a weak base, A minus, plus water. So that's in the given. And finally, we have our titration curve. So titration curve, it's very important because we're going to find our equivalence point. Equivalence point. An equivalence point, if you remember correctly, it's when your pH is equal to 7. And it's also equivalent because the number of moles of the acid is equivalent to the number of moles of KOH. Of course, this number of moles is equal to the concentration of KOH times the volume required to reach pH equals 7. Again, you're adding a base, KOH, onto an acid, so the pH can only go up. So if you do a simple graphic interpretation, just project your curve on the x-axis. You'll get VKOH equals 36 milliliters. Of course, NHA at this point is equal, the concentration, 0.105 mole per liter, don't forget the units, times 36 milliliters over 1000 milliliters per liter. So that'll land you with 0.00368 mole. Again, we're at an equivalent point, so that is the number of moles for both KOH and for HA. That is how much KOH you need to neutralize your acid. So at this point, we have the number of moles for HA, for the acid, and we also have our mass. We know that, very fundamental rule, the number of moles of a certain component is equal to the mass over the molar mass. The molar mass of our acid, in that case, is equal to the mass over the number of moles. If you remember, it was 0.446 grams over 0.00368 mole, which is 118 grams per mole. This means that in 1 mole of your acid, you have around 118 grams of matter. So that's for our first part. In the second part, we want to calculate our pKa. Of course, we know according to Henderson-Hasselbalch's relation, pH is equal to pKa plus the logarithmic of the concentration of the conjugated base over that of the acid, which is according to our equation here. Again, remember that it's monoprotic, so HA and A minus. Now, also, you also know that the concentration of, let's say, A minus is equal to N A minus over the volume. Same thing for HA, number of moles over volume. Again, you can simplify those since you're dividing them, which means that in that case, pH equals pKa plus logarithmic of the number of moles of your weak base over the number of moles of your weak acid. So at this point, all we have to do is remember that in our reaction, first you had 0.00368 moles. You didn't add anything and you had no reaction. At a certain point, when you start adding OH minus, the acid will start reacting to form the base. So let's say it's 0.00368 minus X. X is the quantity of OH minus you're adding, and also the base will start forming, so it's X. And then all you have to do at this point is use the titration curve. Take a random value for your pH. So if pH is equal to 4.2, for example, you'll need VKOH 20 milliliters to reach that pH, from 2 to 4.2. At this point, you can calculate X, which we had seen earlier here again. X is the concentration of KOH, same thing, times 20 over 1000, which is 0.0021 mole. Finally, Na minus is equal to X, and this is equal to 368 minus X. At this point, finally, you just replace your values. 4.2 is equal to pKa plus the logarithmic of 0.0021 over 368 minus 21. So 4.2 is equal to pKa plus 0.97, and pKa is equal to 4.1. So to resume, for the mass, for the molar mass, use the titration, then your equivalence, and then N equals M over M, and then for your pKa, use Henderson-Hasselbalch's formula, pH equals pKa plus log concentrations.